Thank you for joining the Once Changing the World, India's first Future Tech Meets Sustainability podcast. And today, I'm delighted and honored to have with me Mr. Raju Kandaswamy, who's the lead consultant at ThoughtWorks and has recently developed a large language model, Tamil concept model called Tamillama. So Raju, really appreciate you taking time being part of a humble podcast. There are some interesting things happening in the space of Gen AI. Gen AI can do prompt to text, prompt to image, prompt to 3D, prompt to video, prompt to also VR 360 images and things like that. But these are still in its very nascent stage. It will take a couple of years for it to possibly evolve into a space where the output becomes like almost production ready, where people will be able to kind of use that in their work pipeline, be it industry or be it like the consumer facing. How does this generative AI work? What's the background tech behind it? It'll be nice if you kind of explain that, because it's from somebody who's like a layman. It looks like, you just put in prompts and the output comes. What's the background tech behind it? How does it work? It'll be nice if you could explain that.
Yeah. So the background tech is, which does all this magic, comes from the core architecture called neural networks. Okay. Neural networks are, it's not new. It's been there for decades. Neural network is a concept which is designed based on how human brain works, right? Human brain has neurons. Neurons are connected with each other, and that forms the brain, the gray matter, right? And each neuron starts sending signals to other connected neurons. That's how the information is shared, stored, and processed in our brain. So similarly, there is a digital replica of the brain, which we call neural networks, where the neuron is modeled, and when we say train this neural network, the knowledge is stored in the neural network as weights, what we call as weights. You can assume that it's a numeric, it's a number. It gets stored with a neuron, and each neuron can store, a number of weights. So that's what, we call when people say, okay, 175 billion parameter model, right? What do they mean by that? It has got 175 billion weights stored within it. Okay. Let's say, each neuron stores 1,000 weights roughly. Okay, just for the argument's sake, then you can, calculate the number of neurons that might exist in that particular parameter model. So you can assume, like, let's say, 1 billion parameter model is the size of a cockroach, and 100 billion parameter model is the size of the brain of, let's say, an elephant, right? So this is how, the models compare. And how this ability comes from a pure weightage feed. Technically, if you open a neural network model which is stored in the computer file, it is nothing but just numbers, weights, numeric weights. And how this, file of weights is able to, reason and give this creative outputs, right? So this is where the operating model of AI comes into play. Okay. So typically we feed the information as an input, right? And there is something called the hidden layers, right, in a neural network. And this information passes layer by layer. Okay, step by step, and then there will come an output. Let's take the case of ChatGPT-like models, right, where you give the prompt and it gives you an answer, right? So the input prompt goes as an input to the input neurons, and there will be hidden layers. It will, they will start processing the incoming text, and they will start, outputting the response to it. The ChatGPT-like models are designed in such a way that they will predict what is the probability of a particular token to appear next. When I say token, right, you can assume it as like a word, right? It's an English word. And let's say we have a vocabulary of 30,000 words. You have a bag full of words, 30,000 tokens or 30,000 words. And when you send a prompt, the model will evaluate and will pick one token out of the bag, which will be the first token for your prompt. Then it will pick the next token, next token, next token, next token. So like that, it will start constructing the sentence. Now, this might look crazy, right? How a next token prediction model, which can, pick only one word. Now, what is the next possible word for a given sentence? How is it able to, reason and, be creative at the same time and it give a connected response? It's not a random words appearing one after another, right? They are grammatically correct. They are logically correct. And they have the factor of creativity and everything, right? How this is able to, it is able to manage? There was a paper called Transformers, Attention is All You Need from Google. Okay, this is the base paper which has transformed this text to text models, GPT models in general, right? So this paper talks about how it analyzes a given sentence and looks at multiple words at the same time concurrently, and it is able to model how certain words are able to change the construction of the sentence. That's how it reasons it and stores it as a knowledge. At the end of the day, however big model is, they are all next token prediction models. Point blank. Maybe a very small 1 million parameter model or maybe 220 billion parameter model. They all do one single thing. That is predicting the next token. All the architectures remains the same. Where they differ is the amount of data that is fed in. Because 1 million parameter model cannot hold that much of data and it cannot model it, and so we have to go for a bigger model. So 220 billion parameter model, literally they have fed in all data which is digitally available. OpenAI has scrapped the entire internet and they fed the data to train it. So that's where the knowledge, reasoning, and everything, the model is able to see through the sentence. That is where the knowledge comes from. It's not that probability of predicting. Let's say Eddie makes the best podcast. Okay, this is the sentence, right? And a model is trained with it. Okay. You can, transform the sentence and say that the best podcast is made by, and it will finish saying Eddie. You form the sentence any way possible, but it will, be able to reason out even this sequence of words, what will be the right word to choose. Okay. So that is where the magic happens, the reasoning and everything happens. And the level of intelligence is actually in the data, not in the model. The quality of the data that you feed in will form the intelligence. So it's like a pyramid. Okay, it's an inverted pyramid. Okay, you start with a word, then a sentence, connected words, then paragraph, then knowledge. From paragraph, it goes to knowledge because these large language models are able to group a passage of text together on its own. Okay, you might send a passage of text about Mahatma Gandhi, let's say. Okay, and the next passage you send is about a tree. Okay, And then the third passage that you again send it as, Mahatma Gandhi, right? The LLM will independently decide that this passage and the third passage, they are connected because of the words which are, forming the sentence are related. And it will be able to group together. And that's how it forms the knowledge. Now, forming the knowledge is not good enough. Okay, it is like a parrot. Okay, it has memorized everything. Okay, you fed in, 100 textbooks, it has memorized all the 100 textbooks. You can ask, okay, open 100th page and read it. It will be able to give you the 100th page content. Is this useful? It is not useful, right? That is where the concept of fine tuning came in. Okay, you have knowledge. Now, how do I extract intelligence out of it? Okay, the intelligence comes only when we make use of the knowledge to do something, right? So that is where, people started, fine tuning the models, fine tuning it for specific tasks like summarization, sentiment analysis, open book question answering, puzzles, you name it what, it can do, thousands and thousands of things, right? So this fine tuning is done via, again, a data set. How they fine tune is they give thousands of samples. Say, for example, I want to fine tune the model to give question and answer. Okay, I ask a question and the model should answer. So to achieve this task, I should give at least 10,000 such samples, question answer samples, quality data set, feed it into the model, that we call it as a supervised fine tuning. Okay. Once we do that, then the model understands the logic of question answering. And the next time when you ask a question, it will answer it from its knowledge. So that's how this, the end output that you get from ChatGPT is achieved.
You explained it very nicely. Now, earlier, what used to happen is that, these really big companies had the processing, the capabilities, the data centers to, process this humongous amount of data, train it into, fine tune it into creating something very, very useful. But that's kind of changing. It's not just the giants who are building these LLM models. There are small startups, there are individuals such as yourself who are going brave out, because what's happening is that the tech itself is being democratized, through access of data, through access of training your data. There are lots of these platforms which allows you to build your own model. Yeah, so how resource heavy it is to build a generative AI application, both financially and computationally? And are there workarounds to build it frugally? Because there are models such as Llama 2 and Hugging Face. Can anyone make a generative AI application?
So I want to, first clarify that, whatever model that I built is a very small 30 million parameter model to demonstrate that, coherent Tamil can be output from a small model. That is nowhere near, models like ChatGPT or Llama. Having said that, the building intelligent models like ChatGPT or Llama is still the game of biggies. Okay, like Google, Meta, OpenAI, or well-funded startups, right? It's still, it's a game. Microsoft also. Because the challenge here is acquiring that volume of data, then processing it, then, having enough infra to deliver the AI, right? Scaling it to masses, catering, billions of users, right? So 3 segments of problems exist. First, let's come to the data set problem, right? OpenAI has, now facing a lot of lawsuits because they just scrapped the internet and used it for training. Now, a lot of book authors are suing OpenAI because the book content without their consent is being used. Meta is also, facing similar lawsuits. The only company which looks safe at this particular point in time is Google, because Google traditionally for their search engine they had content, and also they had a section called Google Books where they actually licensed books, right? So they have the data for right data for the quality training. So obtaining such data sets is impossible for anyone who is starting new, right? Unless somebody is make this data set available for open public with a permissive license. The data set is a problem. There is a data set called Red Pajama, which is a big data set, but that also contains this books data, which is legally not fit to train the models. Now we need to have a data set which is permissive and also legally compliant to train the model. That is the first challenge. The next challenge is actually training the model. See, the tech is simple. We have the recipe. So that is what is demonstrated in my Tamil Llama model, that technically we know how to build these models. But as the size of the model increases, then the complexity increases, the infra needed to train the model also increases, and that goes beyond affordability of startups and even mid-sized enterprises. Only biggies can handle it. The second problem is the infra to train the large language models. And we need really big supercomputer grade systems running for months together. We are not talking about days, right? And this amount of training, right, they are not sustainable, right? We are literally talking about carbon emissions, which are literally concerning, right? If more and more people start cooking like this, there will be more holes appearing in the ozone, right? So that is the second challenge. Now, coming to the third challenge, which is delivering at scale, right? Even if you have successfully trained a model, now the model is so big, and if you want to serve it to the end users, and that to millions and billions of users, that means that you need to have the support infrastructure, and that should work around the clock, 24/7 and 365 days. That is again a costly affair, and so this is affordable only by big tech.
Thank you for explaining that. So that yes, at this point in time, this still is in the domain of those big tech who can develop, run, and deploy these applications. I mean, it's not so easy. Yes, I mean we can do these small models, but I mean those large models. I mean it is a challenge. You have built a LLM which translates Tamil to English. Would you like to talk a little bit about that?
Yeah. So this stems from a paper called Tiny Stories. Okay. This paper actually talks about what is the minimal size of LLM that is needed to write coherent English. Okay. So they produced a data set. It's a synthetic data set. It is a data set obtained from GPT-4. They have actually created like 2 million tiny stories, like bedtime stories. It has a start, few characters, 2 or 3 conversations. Then there is an ending and there is a moral. It's a very small set of stories. And like this, they have generated like 200 million stories. And with those stories, they trained the model. And it was able to talk coherent English. Okay. Prior to that paper, even to get a model to talk English fluently, coherent English, then you need to train a billion parameter models, and that too for weeks together. That was the uh, state. But what the paper has broke is that in order to talk coherent English, you don't need a billion parameter model. Even a small million parameter model can talk coherent English. But is it knowledgeable? Is it intelligent? That's a different question. The paper did not talk about it. Concentrated on one single thing, which is talking coherent English. Now, what I did is, I took that paper and applied it for Tamil. Okay. So here, the challenge that I had was I don't have a data set, Tamil data set, which, 200 million stories. Right. So I used a tool called IndiTrans to translate all the 200 million stories into Tamil. Right. And that formed my data set. And using that, I trained a small 30 million parameter model, which could actually started talking fluent, coherent Tamil.
What were the challenges you faced building the LLM for Tamil, and how did you overcome them?
So for any, it's not only for Tamil, it is, for any language modeling, right? There are a few challenges. I'll come to the Tamil challenge a bit later. If you take any language, right, there are vowels, consonants, and then some supporting character. This is the character set available for any language. And there is a permutation combination of all these characters together forms a word. Then permutation combination of words form the sentence. Then, paragraph and knowledge and blah, 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 right? Now, so to train any model in a particular language, we need to construct something called vocabulary. Vocabulary is the main main construct for a language, right? In order to fluently talk, you need to have enough vocabulary. Okay. Let me take. I'm a very poor Hindi speaker because my vocabulary is very limited. I'm a native Tamil, so my Tamil vocabulary is better, but Hindi vocabulary is limited to say 500 words. So within that 500 words, I try to manage my conversation in Hindi. Will it be efficient? No. Right? But whereas when I come to Tamil, I have, a bag of, 30,000 or 300,000 words bag. Okay. I can converse very, very fluently. Even if I take English, the same thing goes, right? Now, constructing this vocabulary is an engineering thing, but also needs an understanding of the linguistic architecture, how the language forms words and sentences, right? If we, there is a concept called tokenization. Tokenization is the process in which we construct this vocabulary. Okay. You give a passage of text. Let's say I have the content. Let's take my example itself. There are 200 million stories. Now I need to extract the vocabulary out of these stories, right? So that is the first challenge, which is a process called tokenization. Through that process, I was able to solve this problem. Then the generated vocabulary was not good enough to model the sentences. So I spent, good amount of manual time looking at the vocabulary and correcting it. Where these words need to be split correctly and which are all the frequently repeating words and sentences like that. I had to prioritize and give them weightage, right? So all that thing is the first challenge. And once that challenge is done, then it's just a matter of computing time, putting it to a training program and asking it to execute. Where I failed is that even after, running the training program, at least 3-4 times this training failed because of the neural network structure that I designed is not good enough to how do I put it? the brain that I'm designing, that right? I said the underlying concept is neural network. So this neural network need to be given with the right configuration, like the number of neurons in each layer, how many layers that we put, right? This information is really important. And I failed several times to find the right combination of configuration, neural network configuration, which can, form the sentences and paragraphs effectively. So that comes from experiment and experience both. And after 2 months of continuous try, and the last iteration, the successful iteration, took 2 weeks. Time in one of my gaming grade laptop ran continuously for two weeks, and then it was able to produce the outcome which I posted in the LinkedIn.
Right. So what are the capabilities of the LLM? Maybe talk about that at this point in time. Maybe the limitations of what you built.
So the limitation is that this LLM doesn't have any knowledge as such. It can do only a couple of tasks. It can write a story. It can find character. Given a story, it can find characters in it. You can prompt it to write what kind of story you want. Do you want a story with happy ending, or do you want a story with bad ending? You can also give what kind of features need to be there in the story, with dialogues, without dialogues, with too many characters, right? And at the end of the story, it can translate it to English. And it can do it vice versa. You can give an English story and ask it to translate to Tamil, it will do. But the vocabulary is very limited, because the vocabulary that I designed is small. Say, for example, the word alien, right? The alien word is not available in the vocabulary, and it is not available in the stories. Now, if you ask the model to write a story using aliens, it will not, because it hasn't seen the data, it doesn't understand what alien means, and it doesn't do anything with that. And you can't go and ask questions to it. It doesn't know what is question answering. So that doesn't happen. So these are all limitations apply. But one advantage is that since the model is so small, it can be served using a consumer grade laptop. It will run in any laptop. That is the advantage that we get.
You build out a very basic LLM model. What comes next for you? What comes next after this?
So right now, I'm actively researching on the area of building an LLM which can hold knowledge, right? And also, Tamil language has certain complexities with it. When I say complexity, the written form is different, the spoken form is different, and it has specific forms for music, specific forms for storytelling, specific form for conversations and stuff like that. And it has it's an evolved language, right? And it has got a wealth of information from the ancient centuries, right? From palm leaves writing to digital, we have most of the content available, and most of the best and art forms works, right? Fine art form works, they are available in the poetic form, right? And that is totally different from the current language style and form, right? So if we have to model it, a model need to understand all of this: the poetic form, the conversational form, the story form, right? So all these forms it need to understand. So modeling and training this would be a challenge. And I'm just trying to solve one piece at a time. So right now I'm proceeding to build an LLM which will just construct sentences, full formed sentences in Tamil language with a much better vocabulary, which would make sense for the end user.
It-
Once that is successful, then we can evolve from there, one step at a time.
there are so many models, which does English languages, but there's nothing much when it comes to native languages. I mean, in here, and I hope there's a concerted effort into creating these native language LLM models, which will usually benefit the people of country.
So there is one such effort already in progress by our Indian government, which is called Bhashini. I think you might have heard about it. Bhashini is in the early stages. They are, collecting data, forming the initial data set, which could go into building this tech. Of course, the wheels are moving in the right direction. We might see something happening in this space sooner. And recently, in one of the interview, my head of digital engineering center for ThoughtWorks, my employer, he quoted in one of the interview that the Bharat LLM should be built on top of the India stack. India stack like UPI, like Aadhaar, right? And it should be offered like UPI, Aadhaar, like offerings to the general public, which will actually take the tech to masses, right? So I'm also of the same opinion that if we travel in that direction, we will make this not only make this tech reach everybody, but also make everyone use this tech. This is not the tech meant for only people who are in the field of IT and others, right? We can reach anyone and everyone. Why generative AI caught my attention is that its ability to empower people. It can empower non-technical people to become a technical people, a tech person, right? Say for example, I'll quote an example from IT industry, but you can correlate it to other industries as well. Typically, in an IT industry, developer is the one who writes code, and a project manager or a business analyst is the one who gives requirements for writing the code. Now, what this tech enables is that even a project manager or business analyst, if they wish, they can write code. It is such empowering tech. You are not limited by your knowledge, right? AI has the knowledge. All that you need to know is how to use it, how to use AI to extract, the right knowledge out of it, so that you can learn it, okay, on the fly. Treat it like an assistant. Okay, give it a character name. I treat my AI that I use. I have given it a personal assistant name, and I used to call that. Give it a character. Even if it's possible, try to build, understand AI better, because it's not about okay. Let me put it this way. People think that AI is intelligent. It is not. It is you who is intelligent. The human being is the intelligent creation here. AI is dumb. Okay. I tell this for a reason. Because the AI is as intelligent as its operator. Okay. If the operator is intelligent, AI is intelligent. If the operator is dumb, AI is equally dumb. Okay. Assume that you have an assistant who has the capability and caliber of Albert Einstein. Okay. Now Eddie starts to use this assistant. What will happen? The assistant will become Eddie, right? Eddie will not become Albert Einstein, because Whatever AD thinks is what will go to the assistant and the assistant will deliver. Okay, so the intelligence flows from the originator, which is human being. So once you start conversing and start understanding AI, right, then you start to pick up the intelligence of AI. Okay, you need to know how to converse. There are techniques available. If you want the right output in the right way possible in the shortest amount of time, there is certain way in which you make a prompt. And all these skills will build you when you spend more time with the AI. And there is no template to it. Okay, it differs from domain to domain, task to task. AI will not replace your job, but a person using AI effectively will replace your job. Okay, now you need to become that person. First thing. Now, second thing is, just by using AI, will somebody become intelligent? No. You need to learn certain things in order to become an effective user of AI. If you are an effective user of AI, then you will be safe. You will not be replaced. If you are doing anything repetitive, which doesn't need thinking, then you need to rethink about your suitability of the job, because those are all the kind of jobs the AIs will start replacing.
Where does one start from if somebody wants to learn or build Gen AI application? Where does one start from?
So building Gen AI application is super easy. Okay, unlike building LLM, which is a super complex thing, building Gen AI is super easy. There are two possible routes in which you can build the Gen AI. Okay, one is to use the APIs provided by big tech companies like OpenAI, Google, Meta, right? The second thing is to use pre-trained models like Llama, which is pre-trained and available. There is a repository called Hugging Face. Hugging Face is the GitHub of all AI models, and there are plenty of such pre-trained models available for free. If you have a supporting infrastructure, you can take the pre-trained model, deploy it, and build your Gen AI application. If you don't have the infra, go for the APIs which are provided by the big tech companies, and you can build your. It's as good as building any microservices API-based applications, right? Same thing. Big tech companies offers the AI API, you use it and build your.
Generative AI work. There are companies around the world, be it Microsoft, be it Google, be it Meta, who's working on something called as artificial general intelligence, where the goal over there is to create models or algorithms, machines which could have general purpose knowledge. Microsoft and OpenAI just maybe last year also wrote a paper called Sparks of AGI, where the researchers were hinting that these large language models, which we think are just basic, doesn't understand reasoning. Now they're saying that they are seeing sparks of intelligence over there. How is this going to pan out in this decade and beyond when AI gets more general purpose? Through the course of conversation, you had mentioned that AI is as dumb or as smart as the human developer. So if the human developer is evil with intent, we don't even need to get to AGI. If the human developer has malicious intent, there itself we go towards the doom and gloom scenario. But I hope that we humans are smart enough and we understand and take decisions in building technologies which is human first. So on that note, really appreciate you taking time and being part of the podcast. Wish you the very best. Please keep on doing what you're doing. And to my listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you guys. Bye-bye. Thank you, Raju. Really appreciate this.
Thanks, Eddie. Thank you, Eddie.